Sets are the last data structure we're going to talk about in this series. They are a mutable collection of unique data points with no order. Now, to create a set, you use curly brackets and you separate the values by commas. You can notice that different from a dictionary, there are no keys, and that is the main difference in the syntax. Because they don't have a particular order, you can't use indexing to access a certain value. And you might be thinking, well, there is an order. It's first Toronto at index 0, New York at index 1, and so on and so forth. But if I just print this set 1, you will see what I'm talking about. So first time I printed out my set, you can see Toronto, Sao Paulo, New York, and Paris are in different order. We have Toronto, New York, Paris, Sao Paulo. If I print it out again, we have Toronto, New York, whereas before the first index was Sao Paulo, then Sao Paulo, Paris. So sets are unordered, and because of that, you cannot access a set using the slicing syntax. So for example, if I try to access the value at index 2, I get an error because a set is not an object that you can subscribe, meaning this type of syntax doesn't work. Sets are often used to eliminate duplicate information since it only allows for unique values. So when you create a set from a list with repeated values, they are cleaned up. So you can see here that I first have a list with many integer numbers, and then I'm creating a set with the set function, which is the same as casting, as if you were turning an integer into a floating point number. I'm turning a list into a set, and then I'm gonna print the set here. Now, as you can see, all the repeated numbers were excluded, and just one instance of each number is what we get at the terminal. On a side note, when you declare an empty curly brackets, Python will create an empty dictionary. So if I just try to create a set like this, because dictionaries also are surrounded by curly brackets, if I print out the type of this set1 item that I have created, let's see what comes out. And as you can see, Python is dictating that this set1 item that I created is a dictionary. In order to create an empty set, you have to use the set keyword and then pass in empty parentheses. So if I print out the type of this set now, you can see that we have a set. Now, to add an item to a set, we can use the set function. And as you can see now, Berlin is added to our set. To add items from another set into the current set, you can use the update method. So for example, here I'm updating set1 with the contents of set2. So when I run this code, you can see now that I'm printing set1 and all of these integer numbers are inside our set1. The object inside an update method doesn't always have to be a set, so it is included into our set. We can use, for example, a list. And then all the unique values inside this list will be included in our set with the update method. To remove items from a set, we can use either the remove method or the discard method. So here you can see that I am removing the number 1, number 2, the unique value 2 inside our set, and then over here I'm discarding the unique value 1 from our set. So first I'm printing out 1 and 3 with this print, and then second I'm printing out the only value left inside our set, which is the number 3. Some built-in functions that you can also use in our sets are min, max, len, and sum. And when I run the code, you can see here that the minimum or the smallest value inside our set is the number 1. The biggest one is value 6. The length, meaning the amount of values inside our set, are 6. And then the sum of these 6 numbers is 21. Now let's introduce some new logic operators. If you remember the Venn diagrams from high school, you can compare sets directly to find out what they have in common, what they do not have in common, or their combined items. So let's start with the union operator. And when I run the code, you can see that the union is the combined values of both these sets. To perform the union operation, you can also use this straight bar here. And when I print it again, the same result is obtained. Now we can obtain the intersection of the two sets, meaning whatever it is that they have in common, with the intersection method. Printing out, you can see they only have the values 2 and 3 in both of these sets. Now the intersection method can also be done with the AND operator. And when I print this out again, you can see that both results are the same. Next, we can obtain the difference between the sets. So for example, if I print the difference from set 2 and set 1, you can see that here I'll have all the values inside our set 2 that are not in set 1. If I invert these variables, you will see all the values that are in set 1 but are not in set 2, and it's only number 1. The difference operation can also be done with the minus sign. So just to showcase that they're the same thing, let me exclude that line, and as you can see we get the same result. Lastly, we have the symmetric difference operation. Symmetric difference is the combined values of both sets except whatever they have in the intersection. Print, oh, we have a parenthesis missing. Okay, so as you can see, they have numbers 2 and 3 in common. So whatever we get in return is 1, 4, 5, 6. There you go. The symmetric difference operation can also be done with this little operator. Now let's do a couple of exercises before we wrap up. Okay, so the first exercise, print the largest item in the set. Okay, so pause the video now, give it a shot, and I'll show you the solution in a little bit. Okay, so as we saw today, we can use the max function to find the largest value inside our set. When we run this code, we can see that the biggest value is number 7. Okay, so for the next exercise, find and print the intersection between set 1 and list 1. Pause the video now and I'll show you the solution in a little bit. Okay, so as we saw today, first to convert a list into another set, we have to use the set function, and then we pass inside of it whatever we want to be converted into a set. After we convert this list into a set, we can simply use the intersection method to find whatever we're looking for. And as you can see, we get the result 2, 3, 4, 7. So that was it for today. Thank you for watching and see you next time.